Good day to you all. This is React Bug Catcher, tools and strategies for debugging React applications. And I am Sean McPherson, or Sean McBee. I'm a software engineer at Khan Academy from Pittsburgh, Pennsylvania. This talk was originally given at React Global 2022, but due to a technical difficulty during the presentation, I decided to re-record it for YouTube. Over the next 30 minutes, the goal is to understand what debugging is and know tools and strategies to debug React applications. To accomplish that, we're going to explore three topics. The first is debugging, what it is, why it's important, and how to approach it. Then we'll move on to general debugging steps that will be applicable in any debugging scenario. Then we will dive into tools specifically for debugging React applications, the browser dev tools, and the React dev tools. Here on YouTube, I'm going to be going a little bit slower than I was live, so we might actually go past the 30-minute mark, but because it's on YouTube, you can stop and go back and replay things if you need to. Cool. So let's start with debugging. You can define debugging as the process of identifying and fixing failures in a system. Typically, we think of this in a programming context, but in reality, you encounter failing systems in all aspects of your life. And some of the principles that we cover here will apply to those offline scenarios as well. But for our sake, let's define debugging as finding and fixing problems in our code. These problems in our code are called bugs. In academia, there are some helpful distinctions made between the different types of failures. To keep things simple here, I'm going to refer to everything as a bug. Now, it can be tempting to think of bugs as living creatures that kind of find their way into our code, but the reality is that bugs are introduced by developers, and that means you and me. And since all code is written by developers, that means that bugs exist at every level of your code. From assembly to operating systems to programs to libraries to the application code we author, bugs are everywhere. And as a result, debugging is a crucial part of every developer's work. It's not something that you can try to avoid and still progress in your career. It is part and parcel of the work of a developer. So it's worth your time and then some to get better at debugging. Sarah Drasner, a director of engineering at Google, puts it this way: writing code is only one small piece of being a developer. In order to be efficient and capable at our jobs, we must also excel at debugging. However, debugging is challenging. From personal experience, I can say that the most challenging problems I have faced as a developer have been identifying and fixing bugs. Diomedes Spinellis, the author of Essential Debugging, explains why. Debugging is a very demanding activity, more complex than programming because it requires you to maintain in your brain both the program's logic and its underlying effects, often at a low level. And as we discussed earlier, there are multiple layers of programs where the bug could be occurring. So in order to effectively debug, we will need to dive into languages, systems, and environments that we use to write React applications. But before we move forward with debugging steps, let's take some time to discuss an important prerequisite: the debugging mindset. This is how you think about debugging and debugging problems. And this is important because how you approach a problem has a huge impact on your ability to solve it. And for whatever reason, debugging tends to put people into a negative mindset, one that holds them back from solving. And as a result, you need to fight against the tendency to think of bugs as insurmountable challenges and reframe them as opportunities to learn and grow. This means replacing thoughts like, this bug makes no sense, with, let's find the logic behind this. And how can this even be happening, to, I need to investigate the scenario further, and so on. And this may sound silly, but everything on the left will only hurt you while debugging. And these are all things I've caught myself saying before, sometimes multiple times during the same debugging session. But we can use the statements on the right to train our brain to think of debugging as a challenge where you get to learn and grow. To do that, it might be helpful to reflect on some debugging axioms. And the first is computers behave logically. If there's anything illogical in the equation, it's probably you. We can count on computers to act logically because that is how they were designed. And as a result, we can say that bugs happen for logical reasons. Unexpected reasons, for sure, but still logical. Even the craziest bugs have some logical reason for occurring, which means that all bugs can be debugged. Now, this isn't to say that you will solve every bug that you encounter. There will always be limitations in time, resources, and other factors, but they're not impossible. You can reason through the logic, and we need to think of all bugs as solvable and look for opportunities to practice solving them. Because debugging is a skill that can be strengthened, just like any other skill in programming. There was once a time when HTML was confusing, then JavaScript, and React. Some of you might still find CSS confusing. I know I do. Debugging is just like that. Something that is challenging in the beginning, but something that you can and will get better at with practice. So with the right mindset in place, let's move on to the debugging, some general debugging steps. So the first is reproduce, then research, isolate, experiment, resolve, and learn. By following these steps, you'll be able to resolve all kinds of bugs. So starting in the beginning, the first step is to reproduce the bug quickly and reliably. In order to remove a bug, you first need to be able to see it. Sometimes bug reports will come with detailed replication steps, and these are super valuable. Other times you may have information about the environment in which the bug occurred, like browser and operating system. Whatever your starting point, your first task is to find the scenario that produces the bug. If there are only a few steps to encounter the bug, you're probably ready to move on to the next step. However, if there are a bunch of steps or a special environment necessary to replicate the bug, you might try to automate complex scenarios, if it's possible. That could be creating a test file that interacts with the buggy component and produces the failure, or it could be a script that completes multiple steps in the browser to trigger the bug. There will always be a trade-off and a judgment call with automation, but spending a little extra time upfront to automate the replication could A, save you time in the long run, and B, teach you more about the scenario in which the bug occurs. Once that bug is reliably replicated, you should research everything you can about the bug. Any information about the failure and why it's occurring is valuable. Is there an error message or any logging output? Read that. Read all of it. Is there a call stack? Look for code that might be relevant. Once you have some information, you can start to search around for answers. Chances are you're not the first person to encounter any given bug. By searching for a fix for the bug in question, you can potentially expedite the process of finding a solution. There are 4 places that I tend to search for when debugging at work. Notes on my computer, internal messaging like Slack, internal documentation or wikis, and the internet. And the data say that I'm not alone with that last one. In a recent internal study by Microsoft, researchers found that a majority of search engine queries from developers were concerned with debugging tasks. And most of these involved pasting an error message into the search engine and looking for helpful results. If you have an error message, you can go with that. If not, you can search for keywords related to the bug, like React component re-rendering or infinite use effect or something along those lines. Look for results from official documentation or sites like GitHub or Stack Overflow. Personal websites or blogs can be useful too, as some developers write guides on how to resolve particular issues. More often than not, you'll find some valuable information in the results that you can try. But let's say there isn't an obvious fix from your searching. The next task is to go to the code and isolate the bug. Find the file or function where the bug is occurring. And the more that you can isolate the failure, the better. To isolate the bug, you can trace the stack. If there's an error message, then it usually prints a call stack that you can follow. The call stack shows all the steps that occurred in a computer program up to a given point. This usually takes the form of function calls that you can walk through to find where the failure occurred. React typically has really useful call stacks. Here's an example error from React in development. We can see from the first line that we have a reference error in the file where it occurs, pokemonlink.jsx. The second message prints the whole call stack, in this case, the React tree up until the erroring component. Another way to isolate the bug is to search the code base for a keyword. This could be a bit of text from the error message or a function name from the call stack. Any unique string that seems connected to the bug will help you narrow things down. And you can use whatever tool you want to search your code. There are a bunch of options. Just find whatever works best for you and get really comfortable with it. Another technique to isolate the failure is to reduce the amount of code in question. Let's say you have isolated the error to a particular function. Now look into it and see if there are any blocks of code that you can eliminate and still reproduce the failure. Comment out or remove huge blocks of code that are unrelated. The goal here is to remove as much as possible so that you can focus on the areas where the bug is occurring. And sometimes the code is a little too interconnected to reduce. In those scenarios, you can try to replicate the bug in a sandbox. This entails creating the simplest version of the bug in an isolated environment. For this, I frequently turn to Run.js, CodePen, and CodeSandbox, but there are tons of alternatives out there. If you can reproduce the bug in one of these isolated environments, it's often easier to find a solution. Now that you have the bug isolated, it's time to experiment. And for this, you'll follow the same scientific method that you learned about in school. 1, come up with a hypothesis. 2, run a test. 3, and evaluate if you were correct or not. Depending on the results, you may need to repeat those steps again until you have solved the problem. So first, hypothesize. Make an educated guess. Let's imagine a scenario in which you discover a bug where a useEffect hook is running more than expected. You start the experiment process by making an educated guess. The useEffect in component A is rerunning because a dependency is changing. Then it's time to design a test. You want to make sure to test only one variable at a time. And your test might look something like this. If I remove all items from the effects dependency array, then it should only run once. Once you've completed your test, it's time to evaluate. Answer the question, was your hypothesis correct? It doesn't really matter if it was right or wrong, only that you learned something from the test. After running it, we learned that that clearing the dependency array resulted in the effect running once. So our hypothesis was correct. Once that step is complete, you need to ask yourself, do I need to repeat the process? In this case, we do, since we haven't found a resolution to the problem yet. We can try the following set of tests, which I've abbreviated for time. Add dependencies back to the array one at a time to determine which one is changing. Once you have found your solution, you should resolve the bug and add safeguards to prevent others like it. Fix the bug and add a test to verify the correct behavior. If the bug resulted from a pattern that is used widely across the codebase, consider making those changes as well. It might be painful in the moment, but you and your team will be thankful for the effort in the long run. And finally, learn from the experience. You should file away anything that you learned while debugging for reference later. If you have an internal documentation like a wiki or an issue tracker, add information there. If not, throw the details in a text file that you can reference later. If it was a really challenging bug, consider writing a detailed article and sharing it publicly to help out the next person. Or you again in a couple months when you encounter the same bug. Cool. So we reached our first mile marker. So far, we've learned about debugging generally, what it is, why it's important, and how to approach it. Then we looked at some debugging steps: reproduce, research, isolate, experiment, resolve, and learn. Next, we'll look at tools every React developer has to help them debug problems: the browser dev tools and the React dev tools. I'll use Chrome here, but most of the features that I share are available on other modern browsers. First, we'll look at the browser dev tools. These are the most valuable tool available when building and debugging web applications. You can access them in any modern browser with the keyboard shortcut Control-Shift-I or Command-Option-I. This will open the DevTools window either on the side of the web page you are currently viewing or in a separate window. The DevTools is broken up into multiple sections. First across the top is the toolbar, where you'll find some tools, the tabs to navigate between panels, settings, and a menu. Next, in the yellow, is the panel, which can be divided into a number of panes in green. And last up from the bottom in blue is a drawer, which can be opened or closed by pressing Escape. Within each of these sections, there are some UI features that you will use. In red, tabs are for selecting a new view for that region. In blue, a 3-dot or kebab menu for options. And in green, a settings icon to configure the region. To illustrate all these tools, we'll be debugging a little app I created called the React Bug Catcher. This URL will take you to the app on Netlify, and there's a link at the bottom of the app to GitHub where you can get the source code. I'll be using the development version of the app, but I've turned on source maps in production, so you'll be able to follow along without cloning. It just might take a little bit longer. In the app, you play the role of a bug catcher and try and collect and catalog all of the Pokemon, all the bug Pokemon from the original game. So we can go over here to the Explore view. We can attract bugs by tossing out raspberries. Nice. And when one appears, you can try and catch it by tossing a netball. Cool. I just caught a Caterpie. Once you've caught a Pokemon, you will see the count in your Pokédex. You can see the 1 for the Caterpie. And then if you look at an individual entry, you can add a Pokemon to your favorites, or even add some notes. Little bug boy. Cool. It's a little silly, but for our purposes, it should work. So with the app up and running, let's look at the first panel, the Elements panel. So this is the default panel, and it shows you all of the markup for the page you are currently viewing. Now there are 2 features that I want to highlight that I find useful while debugging. The first is Find by String or Selector. It's nice to be able to explore the DOM to open these different nodes here, but for large trees, it can be difficult to find the element that you're looking for. If they're visible on the screen, you can use the element selector up here to highlight the markup, in the main pane here. So I can find this little B tag as well. But when the element is invisible or potentially absent, you can search by selecting this main pane and then typing Command or Control F. This will bring up a little input where you can search the DOM for a string or selector. So I can type the text of a link like pincer, and the pane will show me if there is a match. In this case, there are two. The first is the image, and the next is the content of this bold tag. Pretty handy. You can also type CSS selectors for more powerful queries. So I can search for a link that ends with the string 10. Cool. And it will highlight that element for me. I think this is super powerful, and the fact that you can build these complex queries. Searching for elements is really useful when you're trying to connect components to their associated DOM elements or see if a component has rendered on the page. The next thing I want to highlight in the Elements panel are the accessibility features. So let me pull this out just a little bit further. So we get our sidebar here. These features provide us information about our app that we can use to create inclusive experiences for everyone. So first, using the element selector, I'm going to hover over the heading, and we can see here in the popover some accessibility information like color contrast ratio, the name, the role, and whether the item is keyboard focusable or not. This is super valuable, and when you want more details, you can select the accessibility tab from the secondary pane. So here's the main pane, secondary pane, into the overflow menu. Let's click accessibility. And then let's look at a link. Cool. So within here, we have additional information that we can use when debugging like navigation in your app with screen readers or something like that. There's even some settings that you can enable to show the order of the elements within. So definitely a useful feature to know about. After the Elements panel, the next panel is the Console panel. React and JavaScript developers are probably already familiar with this panel, but there's two features that I find really useful when debugging. Some of the settings that are hidden and live expressions. So first, the settings. There are a few options hidden in the console settings that I find valuable when debugging. The first is preserve log. This will keep your logs even after you navigate or refresh the page. And this is super handy when you want to compare two logs side by side, but they're on a different page or it's after something has been refreshed. So with this enabled, I can navigate to a new page and see the previous log requests. So let's go to the Butterfree page, and all of my console requests are still there. Or if I hit refresh, I can see that too. Maybe let's see a little bit better. Cool. And the final one is to log XML Http requests. So this will give you an abbreviated record of any network requests without having to navigate to a new panel. And this is nice if you want to make sure that a request is being made, but you're already looking at the console maybe for something else, some other information that you've logged there. So I can refresh here. You can see this little fetch where it has some get, and it has the little stack of where the call came from. Pretty cool. These options and others are handy, and I often find myself toggling them on and off while debugging. I'll turn them off for now. We'll close that again. Cool. The next feature is live expressions. And this is a live readout of any value that is available in JavaScript, like a global variable or computed value. So I'm going to clear things to get things neat. And then clicking on this little eye icon, I'm going to type my expression and do date.now. And we can see that at some interval, the browser is computing this value and giving us the most up-to-date result for it. This is a bit silly. You wouldn't really want to do that. My favorite example is to is when tracking focus with document active element. Cool. So now when I interact with the page over here, I can see the active element as it's switching around. This is super helpful when you're debugging issues with managed focus, where you're like specifically moving the focus to different elements. Cool. The next panel that we're going to look at is the the sources panel. So here we can see all the source code for our program and step through the execution. To introduce these features, let's open a file with Command or Control P. Let's go to the Explore view. Cool. And then I'm going to look for my component, explore view. Nice. I'm going to use the full path because this is the one that hasn't been minified. Now I want to know what happens when you toss a berry. So I'm going to look inside here, my source code. Here's the name of the component. Here's some of the functions and variables. I'm going to add a breakpoint within our toss berry function by just clicking on the line number here. We can see that we've added a breakpoint. Now when I toss a berry, I get this dark overlay over our app with the banner at the top to let me know that the execution has been paused. And with everything paused, I can look at the value of all the variables in scope under closure. So here in the side pane, if I go into closure, I can see the value for all of these variables. And having access to all of these variables is much better than console logging everything. I can also step through the code with the tools here. And then when I'm all done, I can hit play. Cool. Ooh, nice. Pokemon appeared. So let's add a new breakpoint to our application under encounter Pokemon. So scroll down a little bit further. We'll do it right here. First, I'm going to catch this Metapod. Nice. Okay, now let's toss a few berries until we encounter one. Oh, nice. Right away. So we can say the same variables here in closure, but we also have this other section up here that has all of our local variables. And these show the values as they are being initialized. So currently nothing's been initialized, they're all undefined. But as I step through my code, those values will fill in. Nice. The next section is the call stack. So I'm going to collapse this, which shows us all the functions that were called up until this point. You can see most of the stuff is internal React stuff, React DOM development, all that type of stuff. But we can see some of our own code at the top. We can see that encounter Pokemon was called by tossberry. And this is a helpful feature to reach for when isolating a bug that you encounter. There's a lot more to look at here, but for the sake of time, we're going to move on to the next tab, which is the network tab. This shows you all the requests made to load and run your application. And this is a go-to resource to make sure that your app is getting all the data that it needs to function. There are two helpful debugging features that I want to highlight. The first is verifying network requests and responses. And you can see some information in this table already, including name and status and initiator. And if you're looking into some performance issues, then size and time and waterfall will be really helpful too. When you select one of the responses, you get some additional information about it. So if you're debugging an unexpected failure or response, you might want to check the headers and payload to make sure that everything is what you expect. You can look at the raw response, or you can explore it in the preview menu. And then finally, the initiator includes a call stack that you can trace to isolate the bug. So if you want to know where this fetch request is coming from, you can find it here in the initiator. We can verify that code splitting is set up correctly by disabling the cache and filtering for JavaScript requests, and then navigating to a new page. So I'm going to clear this. I'm going to navigate to my new page, and we can see that we loaded this all view separately after navigating from one view to another. So we can verify that it was lazily loaded and our system's working correctly. The next feature I want to highlight is screenshots. Sometimes bugs are visible only on the screen for a short amount of time, and they're easy to miss. The network panel has a feature to capture screenshots while a page is loading, which can then often identify those types of bugs. So if we click here on the settings menu, and then we select capture screenshots, it's going to invite us to reload the page. So I'm going to do that. Cool. And then we can see the screenshots of the page as it was loaded. So I'll double click here. Sometimes the first screenshot is just when you first hit refresh, but after that point, you can see the loading state. Things start to load. Cool. As the page goes. The data load kind of dynamically. Nice. So from between these two screens, I can see that our Google font loads and kind of shifts the layout a little bit. And that's definitely a bug that I would want to look into. Cool. Now the final DevTools panel that we'll look at is the application panel. This has a lot of information about a lot of things, but we're going to focus on the storage features. The first is to edit local and session storage. So here in the secondary pane, let's select on storage, go down to local storage, and then the domain. This will show us all the local data for our application. So you can see we've got notes, our catch count, and any favorites that we have. Here we can add values or edit existing values. Let's increase the catch count for one of our Pokemon. Let's say that I have 100 Caterpies. Now if I go over here and refresh my application, that value is reflected. It's pretty cool. Cookies are similar, but permissions might prevent you from editing values. In our application, you can see that we have berries and balls set in cookies. So we could manually set the number of them to reproduce specific app states, or you could just give yourself 100 berries and balls so that you can catch all the Pokemon that you want. Go back to Explorer, we have those values. Clicking the X icon can clear an individual cookie, which is helpful too. Refresh our app, it should handle that scenario. Nice. Finally, when reproducing a bug, it's important to start with a clean application state. And here in the application panel, you can clear all of the stored data by selecting application, storage, and then here, clear site data. This clears local and session storage, cookies, cache, web workers, everything. And as a result, it may mess up your authentication state. So just something to keep in mind. But with that cleared, we can go back and all the data is gone. Nice, clean slate. With this, we could try reproducing the bug without any baggage. And that brings us to our second mile marker. In this section, we learned about the browser DevTools and 5 panels: elements, console, sources, network, and application. Now let's move on to the React DevTools. These are a set of tools that the React team provides to help work with React applications. And these will probably be your go-to tool when debugging React apps. We'll be using the browser extension, but there is a standalone package that can be useful in other scenarios. The extension adds 2 panels to the browser's DevTools for debugging: components and profiler. First, let's look at the components panel. So going over here into the overflow menu, I select components. The main pane here shows a tree of React components that makes up the current page. First, you can navigate the tree by filtering with a string or regex. So I could search for maybe Pokemon or something like that. And it shows me all the results that I have. So this application used styled components, and as a result, it adds a lot of noise to the tree here. So what I'm going to do is I'm going to go to settings under components, and I'm going to add a little filter here where if the name matches this regex string, what is it? Styled.star. Cool. And I close that, cleans up our tree a little bit, which is nice. Cool. So once you find the component that you're looking for, you can select it and see more details here in the secondary pane. So let's go to the all view. Over here on the side, you can see any props that the component is passed, any hooks that it calls, and information about the stack where it is rendered. Nice. If we click this little magic wand icon right here, we can actually have the names of our hooks rendered for us. So I can see that there's in my code a variable called all that refers to this data here. There is a setting to automatically parse the hook names here under settings. Always parse hook names from the source, but React warns that it may be slow. And also it's easy enough to just click the magic wand icon when you need it. So I tend to not select that option there. Cool. Now, some of these values can be edited. So like if we open up the state value here, and maybe I want to change the name of a Pokemon to Wormboy. And as soon as you make that change, you can see it reflected over here in the DOM because React treats that as an opportunity to re-render from that point. This is really helpful whenever you want to recreate a state for your application. You can go in and manually change the state values if that's faster than interacting with the application yourself. Cool. You can also navigate from the secondary pane. So if you want to jump to the DOM element, you can click on this eyeball icon. This will actually take us to the elements panel. So from all view to the elements panel, let's go back here. If you want to look at the source code, you can click here on the angle brackets. This will take you to the sources panel. Also pretty handy. And then finally, in this rendered by section, you can navigate to ancestors in the tree by just clicking on the name of the component. So here I can jump back up to app, or if I select a component that's a little bit further down the tree, I can go from Pokemon link to all view to app. And being able to trace the data flow is really helpful as you're trying to get your mind wrapped around the React application and trying to debug how that moves down the tree. Cool. The second panel from the React Dev Tools is the Profiler panel. So once again, over here in the Overflow menu, we're going to go to Profiler. This is from a previous recording. So there's a lot you can do here to analyze the performance of the application, but we're going to focus on the features that will help you when you're debugging React apps. The first is to highlight component updates. Now, frequently when working with React, you'll encounter components that are rendering when you don't expect it. The DevTools here have a feature that will help you visualize when a component is re-rendering and hopefully help you identify the issue a little bit faster. So if we click on the Settings menu here and go to the General tab, you see this option here, Highlight Updates when components render. If we select that, and then maybe we go to an individual Pokemon here. Now, whenever I trigger a render, maybe like adding it to my favorites, I can see this little flash of blue as the different parts of the component re-render. So it's nice and it's useful to have this option available to you. I tend to have it selected all the time just because it's nice to know when things are re-rendering. Now, knowing that a component re-rendered is helpful, but knowing why is usually better. And for that, we need to generate a profile of our application using the profiler here. This will give us a window into the time it takes React to run our application and can give us more information about why a component is rendering. So let's go back into Settings, this time the Profiler tab, and we're going to select this option, Record why each component rendered while profiling. Nice. Let's close that. And now we need to create a simple profile. We do that by starting the Record button and then interacting with our application state somehow. So I'm going to remove my this Pokemon from my favorites and then stop. And so you can see here, I now have this nice handy flame graph of my application, of this profile, the application that I took. So this graph here is similar to the React tree that we've looked at before, but in this case, the length of the bar corresponds to the amount of time that React took to render that component and all of its children. Now we can see in the pop over here that all of these gray components here did not re-render when this changed, which is helpful information. But let's get down to the first colorful one, which is the Pokemon view. And we can see now, why did this render? Because hook 2 changed. And that's some valuable information. We now know exactly why this component re-rendered. And so we can start tracing from this point. I'm going to click on the component here. You can see a little bit of additional information, including all the children from this part of the tree. Should be helpful to look into. But I want to know more about hook 2. That's just the second hook that was called. It doesn't actually provide me additional information. So what I'm going to do with this component selected, I'm going to go over to the components panel, and then, sometimes that happens. Let's try again. I'm going to have Pokemon view selected, and then go over to the components panel. It should, there we go. It should have Pokemon view selected automatically. Sometimes it's not really a big issue to try and find it anyway, but it's nice when it already has it selected for you. Cool. So now I know that hook number 2 was the one that re-rendered. And so if I use my magic wand, I can see that hook number 2 is my isFavorite variable. So that variable changed, which caused the re-render. So this is super helpful. Now I know why this component was re-rendering. In this case, it makes sense, but there are other scenarios where you might not expect a value to be changing or a hook to be firing again. And then you can kind of trace this flow to figure out why. There's a lot more that could be said about the profiler panel, but I think this is a good place to stop for our talk on debugging. That brings us to our third mile marker, which means we're nearly done. In this section, we learned about the React Dev Tools and its 2 panels, the components panel and the profiler. We learned how they will help you analyze your React application, both individual components, and then answer the questions of when and why they re-render. So our goal in this talk was to understand what debugging is and know tools and strategies to debug React applications. We covered debugging, why it's important, and how to approach it. Then we learned some general debugging steps before diving into tooling. We covered 5 of the browser's DevTool panels and 2 React DevTool panels, and saw some features that you can use to debug your React application. Altogether, these provide a versatile and powerful tool set for debugging any React application. that's all from me. Thank you for your time, and feel free to check out any other videos that I have on my channel. All right, later.